My name is Luis Bernal, CEO from Realists, and first of all I want to thank you for your presence here, and I will present the new model for our company, RealSpine Deformity, and say that's the first patient-specific reality deformity model. When we built the company, we try to change the paradigm of the training. When we see how right now cadaver training are positioning like the gold standard in the theory and surgery, and we see this gold standard not anymore actual for the times, also for the technology. And we try to introduce new standard paradigm with realistic models that we already established in the minimally invasive surgery. The company was founded in 2050, but we have more history. It's a spin-off of the University of Applied Science in Leipzig, Germany. And we are very proud to say that we were the company that made the first cadaver-free training worldwide in spine, with realistic conditions, using realistic instruments, realistic visualization, microscope, and also these models make possible to have the complete workflow of the training, from patient-specific briefing, operation, preparation, and feedback. And this is only possible because all our models are based on real patient cases. We start with some international expansion in the USA 2021, and right now we are very proud to say that we have the complete ecosystem for training for the all spine-based model, from minimal basic and basic training to deformity training. The main characteristic of the models is very realistic modeling with bleeding CSF that we introduced for the minimal invasive surgery. For deformities, it is possible to increase the realism. Right now we have a basic model, but we can increase the realism with bleeding, CSF, and so on. How we develop these models? Mainly, we take all the knowledge that we get in these 10 years of the company in minimally invasive about how precise is the haptic with the different ligaments, different bone, and all this knowledge we transfer in the development of these deformity models. Of course, for us was a learning process because of course you have a lot of deformities in the minimally invasive surgery. There is the genetic deformities, but not mainly bone deformity, and that's something that we learn in order to develop these models. But all the know-how about materials, about the right materials for soft tissue, the right materials for the bone, we transfer this know-how and this models. And that's important because we say we have this 10 years experience that we take and move to the deformity model. Of course, very challenging to make a simulation of multiple correction, but I can say we get with this model a good model that not only represent the realistic the translation correction, but also angle correction. That's something that you can make completely in the model. As I said before, the models are based in a real patient case. Because for us it's important that the model can translate the complexity of the operation that you have in the operation room for the education purposes. And that means we can use this model and see also all the complexities that you have in the operation room. And also to see that we have the haptic, the dimensions, and the actual scales of the real patient case. Sometimes the model may be escalating or to make a small model, but we have to have really real escalates of the bone in all the soft tissues. Of course, it's not that the model will be made only for engineers. We validate the model also with surgeons in order to get the feedback about the realism of the deformity studies. This is the realist model we make on the basis of, as already said, a real patient case with two major curves. Right now, the model that we see here, we concentrate in the thoracal curve, and that's something that we can do. Normally, the minimally invasive case, what we do is we take patient cases, we segment the cases, and we use this in order to reply like 50, 100 times for the serial production. But it's also possible to make patient-specific cases and put in this system to make patient-specific training or the patient-specific preparation of operations. And you will have the chance to see here the model after the presentations. You can come here and see how realistic is also the haptic of the bone and the different soft tissues, and also the possibility to make the correction in a realistic simulation of the forces. What we achieve right now with this model is to have the unique, complete realistic simulation portfolio in Python. For us, we are very proud to say we can make cover the training from the basic training to the advanced training. To make trainings also not only for posterior approaches, for lateral approaches, also with different technologies, with endoscopic, with microscopic, and very important also, all the models are compatible also with navigation, robotic, and X-ray. In this way, you will have, or you can make the training in a similar condition that you have normally in the operation. We have also additional technologies like real imaging. This is like a navigation for training, but we offer this compatible with other these products. That means if you need some X-ray, we have X-ray. We have also technology in order to have the training flexible. You can make the training here in the hotel, in your hospital, and this is one of the main advance of the use of simulator, to have flexibility in training. We offer also complete solutions like a real lab. We have a real lab in Leipzig in the US in Texas Back Institute, that we have all the instrument, equipment in order to make the training. You only have to come and make the training without any concerns about if you missing instruments or some equipment that you need in order to have a successful training. And something that we are moving in the future, because I think training need not only subjective feedback but also objective feedback. We're including in the models also some sensors in order to have live view of the changes or the improvements on the for the operation. We also make possible to give feedback to the residents about what the improvements in the learning process. If we want to resume the benefits of this kind of models, first of all, I think for the surgeon, there are options to have a better preparation of the cases, and also to have to analyze all the challenges of the complexity of cases, but before you have the patient case. You can make the first training or the first operation with the model, and you can see all the challenges of the operation, and then you can go to the operation room with a better preparation background. You can also define your strategies for correction with the model. That's something that you maybe will see when you are on the patient phase, but here with the model, because you have similar conditions, you can also, before the operation, analyze what these strategies have changed for the correction. And one additional advance, I think, that is for the patients, you can make also a briefing with this kind of models. You can explain the patient what you want to achieve with the surgery, how they will be feel more comfortable with the operation. For medical companies, of course, they can demonstrate in a real case the advance of the technologies, and they can also increase the adoption of new technologies. Because the surgeon could be seeing how the technology, we have to have the benefit with the model. No, you don't have to wait to use the operation. And for the hospitals, cost reduction, I think that will be an important factor. You can better plan the operation with the model. You can plan better the implants that you will use with the model. And when you go to the operation room, this plan will have better reduce of the cost of the implants that you can use. You can make better the planning of the instruments and implants that you will use for the operation. Of course, greater safety for the patient and surgeons with a better preparation of the models. Full flexibility, as I already said before. You can use the model wherever you want, in the hotel, also in the hospital. That's something that we already make in minimal invasive training. We bring the model to the hospital, and maybe Saturday, Friday, the night, you can use the operation room with the model and make the training with your team. And something that I see that's very important for the new generation, you can better train new surgeons in scoliosis surgery. Right now, I think it's very difficult to bring new surgeons to learn this kind of operations. with the model, you have the option to be flexible with this training, to maybe also to bring new science that they go to the scoliosis, and I think you can accelerate the adoption or the motivation of the science to get the scoliosis as an option for the professional way. I mean, the HAM study group is also important for research, and research, I think, very important thing for research is elimination of bias. With a model, you will have the same conditions for studies. You can repeat a lot of times the same conditions, and you can make better studies for scientific studies. You have a controlled environment. And sometimes when we have some maybe for adult cadaver training, you cannot control the environment. With the model, you know what you need. You can have this controlled environment for studies. And additional thing that a patient-specific model, you can make study-specific models. If you have some duration in some scientific studies, you can define the conditions, and you can work with a model that is better for the study conditions. What is the future? As already said before, patient-specific models for operations. This is something that we can make also to have not only standard models for testing, but patient-specific models. And we are also making some research about force sensors, and for scoliosis it's important to see how these forces, how they active during the correction. And we are working also to have some tools for live correction angle view in the training process, and try to make also automatic evaluation of the correction strategies. The ideal way would be to have every exploration operation has to be previously prepared with a RealSpine model. That's something that we want to achieve in the future. I thank you. You have the website realists.tv, and if you have any questions at the end, we have.